Hello and welcome to problem 319. Eddie is arguing with Tana about the probabilities of different outcomes when flipping three coins. They decide to flip a penny, a nickel, and a dime. Which would be better? To find the sample space, a systematic list, a tree diagram, or an area model? Justify your answer. Well, here's the thing. We can't use an area model because there's more than two variables. If it was just flipping two coins and those coins were independent, area model would be just fine. But as soon as you get to three variables, can't use an area model anymore. So we can't do that. You could do a systematic list or you could do a tree diagram, depends on what you like. I think the tree diagram will help you get the systematic list. Determine the sample space of all possible outcomes. How many outcomes are there? All right, well, let's do a sample space. Let's do a tree diagram to figure it out. We're flipping a penny, a nickel, and a dime. Let's do the penny first. The penny could be heads, or the penny could be tails. Then we will flip what, the nickel? The nickel. The nickel could be heads, or the nickel could be tails for each of these. Then we'll flip the dime. And the dime could be heads or tails. That's a terrible H. Heads or tails. Heads or tails. The dime here could be heads or tails. So the dime is in black, nickel's in green, penny's in blue. So my overall sample space here is it could be heads, 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 tails, heads, tails, heads, heads, tails, tails. See, this just helps me to organize all the possibilities. Heads, tails, no, tails, heads, tails, 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 heads, and tails, tails, tails. 1, 2, 3, 4, 5, 6, 7, 8. These are the 8 things that are in the sample space. Now we can answer the questions. What's the probability that we get 3 heads? Well, that is going to be just here, right? 1 out of 8. So there's my answer, 1 out of 8. What's the probability we get 1 heads and 2 tails? Where does that happen? Here, 1, 2, 3. 3 out of 8. At least 1 tail. Well, that's going to be here, 2, 3, 4, 5, 6, 7 out of 8. And exactly 2 tails. Well, that's going to be this one, that one. 3 out of 8. Which is more likely, flipping at least 2 heads or at least 2 tails? They're going to be the same. At least 2 heads, that's 1, 2, 3, 4, 4 out of 8. At least 2 tails is 1, 2, 3, 4 out of 8. So those are going to be equal. Have a great